Welcome back, KSDS scientists. Today we're going to continue our study of motion. So our essential question is still, how can we determine and describe an object's motion? But our new topic for today is we're going to be talking about two things, speed and velocity. So let's start off with speed. So speed is the distance an object travels during 1 unit of time. So in order to calculate an object's speed, you would use this equation. Speed, and really I should say the average speed, is equal to the total distance divided by the amount of time that goes by. Now, the unit of speed can vary a lot depending on what unit you're using for distance and what unit you're using for time. But it should always be a two-part unit where the top part, the numerator, is some unit of distance and the bottom part, the denominator, is some unit of time. So for example, in our car, we may record our speed as miles per hour. Right? So miles is our unit of distance and hour is our unit of time. So that's one we're familiar with. If I was trying to measure the speed of this snail, I might measure it in millimeters per minute because the snail doesn't go very fast, so it probably doesn't make sense to be measuring it in miles per hour. If I'm trying to measure the speed of Usain Bolt as he runs down the Olympic track, I might measure it in meters per second. And so your unit will vary depending on what the object is that you are measuring the speed of. So here's just a quick example speed problem. So it says a bamboo plant grows 15 centimeters in 4 hours. At what average speed does the plant grow? So I remember my equation is speed equals distance over time. In this problem, I'm solving for the speed, which means it should tell me the distance and the time. So 15 centimeters, I recognize that that is my distance, and 4 hours is my time. So I'm going to plug in those numbers. So speed is equal to 15 centimeters over 4 hours. So my answer will be 15 divided by 4, which is about 4 centimeters per hour. Now let's talk about velocity. So velocity is a little bit different from speed, kind of in the same way that displacement is a little bit different from distance. Velocity is equal to speed, but it also has direction. Just like displacement was kind of similar to distance, but also included a direction. So just like displacement, velocity can be either positive or negative. The positives and the negatives telling you about the direction of the movement, whereas speed can only be positive because it doesn't include direction. So the equation for velocity is that the average velocity, which sometimes we write as v average with a little avg subscript, is equal to displacement, which remember can be abbreviated as delta x over time. And so, for example, this car's velocity could be something like 45 miles per hour, and it's going east. It's going this way. So it has speed, but it also has direction. Whereas Usain Bolt's speed as he runs down the track could be 10 meters per second, and because he's headed this way, which remember in physics is considered the negative direction, I could put a little negative in front of it for negative 10 meters per second. So now let's look at a few velocity practice problems. So a couple of strategies when doing these problems are that first, you want to figure out what is it you're solving for. Which part of the velocity equation are you trying to figure out? Are you trying to figure out the velocity? Are you trying to figure out the displacement, or are you trying to figure out the amount of time that the motion took? And secondly, you need to make sure that your units are in agreement. And so we'll address each of these issues with each of these example problems. So in my first example problem, it says a blue whale swims 150 meters west in 30 seconds. So I recognize this as my displacement, so I'm going to label that delta x, and this is my time. And it says, what is the whale's velocity? So that's what I'm trying to find out is velocity. So let me write my equation. Velocity is equal to displacement over time. So I can plug in what I know. So I know 150 meters west. I'm just going to use the number for now, and I'll put in the west again at the end. And the time is 30 seconds. And so if I do the math, I get that velocity is equal to 5 meters per second. But I know that velocity needs to include direction. And in this case, I'm going to use a direction word because that was given to me in the problem. So 5 meters per second west would be my velocity. Okay, in this next problem, I need to use those strategies again. So it says a car is traveling with an average velocity of 45 miles per hour east. So I'm actually given the velocity here, so I'm going to label that V. And it says, how far will the car go in 1 day? So that's my time. And what I want to know, how far will the car go, is its displacement, right? That's what I'm trying to figure out. So I'm going to write my equation, velocity equals displacement over time. And I'm going to plug in what I know, which is 45 miles per hour equals displacement over 1 day. Ooh, so I notice a problem here, which is that my velocity is in miles per hour, but my time is in days. If I try to start multiplying and dividing these numbers, I'm not going to get an answer that makes sense because the units are not in agreement. So I need to do one of two things, whatever is easier. I either need to make this velocity be in meters per day, or I need to switch this time 1 day to hours. The second of those sounds easier to me because I know how many hours there are in a day. So I'm going to switch this from 1 day to 24 hours and try again. So 45 miles per hour is equal to delta x over 24 hours. And now I need to solve for delta x, my displacement. So I'm going to multiply both sides by 24 hours. 24 hours. You'll notice that the hours cancel. And if I do 24 times 45, which I'm going to pull out my calculator for really quick here, I get 1,080 meters. Is how far it goes. Now remember, displacement also requires a direction. So I'm going to write 1,080 meters east. Okay, last problem. It says a student drops a ball from the top of the bleachers and it takes 1.5 seconds to hit the ground. So that's my time. If the ball was falling with an average velocity of negative 10 meters per second, so that's my velocity, what was the ball's displacement? So I'm trying to figure out delta x. So I'm going to go ahead and plug this in. Notice that negative sign on velocity. Remember, that tells you direction. And this kind of makes sense because they're dropping a ball. And remember, the downward direction is considered negative movement. So let's go ahead and plug it in. I'm just going to do a little double check of my units. It looks like velocity is in meters per second, and my time is in seconds. So that shouldn't be an issue at all this time. So velocity equals delta x over t. So negative 10 equals delta x over 1.5. So in order to solve for delta x, I need to multiply both sides by 1.5. And I get, as my answer, delta x equals negative 15 meters. Now remember that displacement also involves direction. So this negative sign is telling me that the ball moved downward in its displacement. So that makes sense since we dropped the ball. So that would be my answer. Okay, now it's time for you to try some practice problems. Let me know if you need help. Thanks for watching.